Good morning. We're working on related rates and we're looking at word problems, and almost every word problem you'll have, or excuse me, every related rate problem you'll have will be a word problem, okay? And so did I draw a picture here? And was it a right triangle? And then over here I had the ladder, and the ladder's 20 foot, correct? And did I make this a right triangle? And did I call this X? Did I call this Y? You don't have to call it that. I just think it's, for me, it's easier. Reed, was I talking to you about this one? And did I write this? Where did I say this? It says, the ladder is pulled away at a rate of 2 feet per second. They always have to give you a rate, folks. Okay? You understand what I mean? There'll be something per time. And you have to decide this 2 feet per second, what is it in your drawing? Did I say this is dx dt? Because it's being pulled this way and x is changing, correct? And that means y is dropping, correct? And so we have to figure, it says, how fast is the top of the ladder coming down? So we're trying to find dy dt. Would you agree with that? And I was thinking about this yesterday as I was walking my dog at Quarry Park. Do you know where Quarry Park is? Okay. And I was thinking about this, and I was thinking, what formulas do we know from right triangles? And I think you use the area of a triangle, correct? And so that would be, in this case, A would equal 1/2 xy. I think that's what you told me. Is that correct? Do you know any other formulas of a right triangle? Okay, so what would it be in this case? Well, let's just write the whole thing out and worry about it later. Yeah, can I write 400? Okay, because we have this skill, we don't have to get y by itself because we have implicit differentiation. We know y at that moment, okay? But it's changing, correct? Okay, so you want to make, you bring up a really good point. They tell us what y is at 12 feet, correct? But is it always 12 feet? No, just at that moment it's 12 feet. So we want, remember how I was having you write that general formula? We want the general formula, and later in we'll put in the 12 feet. Now, is the ladder always 20 feet? Yeah. Does everybody follow that, why I put a 20 there rather than a c squared? Okay. Do you know any other formulas that deal with a right triangle? Yeah. Yeah, what do we call that? But this isn't always 30, 60, 90 because those angles are changing, right? But what you're talking about falls under a group of relationships we have. You're making it a little bit more complicated. It starts with a T. And Ryan, yeah, Brady. The trig ratios, right? And so over here, I'm not going to list them all, but we also have the trig ratios. We will use these to figure out rates of angles changing. Okay? And since we don't have that, what's changing is a length of a side of a triangle. Would you agree with that? The length of this side is changing because this ladder is falling. And the only thing that's constant is this 20, correct? Now notice they give me a rate of another side. They don't talk about anything about area. So I'm going to cross this one out. The choice that I have is this one because I have the relationship between all three sides. Is that kind of making sense? Why I'm choosing that? Alrighty. So, Reed, you ready to do implicit differentiation with respect to time? Okay, let's take the derivative. What are you going to get? I got multiplied by the rate of x, correct? Yeah, I'm going to do that. I agree with you 100%. I'm going to make it general at first and then plug in stuff. Okay. Yeah. Plus equals 0. So let's start plug. Can I get rid of these 2's, Reed? Do I need them? I can divide everything by 2, correct? So do I know x? Okay, now somebody in here, John says, yeah, I kind of do know x. At the instant, do I know x? Okay, how do I know the instant at x? Because this says 12 feet above the ground, so this is what right here? Y. So at the instant, y is equal to 12. Can I figure out x? Okay, how would I do that? Yeah, so I could plug 12 in for y here, correct? So I'd have, do you know what 12 squared is off the top of your head? 144. Over here I have x squared, over here I have 400, correct? So I get x squared equals, I think that's 256. Yeah. And so that means x has to be, 16. And I know it could be positive or negative, but negative is dumb in this case. Would you agree? So now I know, everybody okay with that? Everybody okay with that? So, but that's only at an instant. In a tenth of a second, that'll have changed. So I'm going to have 16 times, what did you say the rate was? 2. Can I just put a 2 there? Okay. Plus, do I know y? 12. And I'm trying to figure out dy dt, correct? Once you get to here, the math becomes pretty easy, doesn't it? Yes, ma'am. Yeah, I divided everything by 2 and got rid of them. Oh. You understand what I'm saying? Yep. I'll just do that right away so you know what happened here. And here's the reason why, Hillary. I could have put the 2 in there. It's just greater chance of me screwing up. Yep. Okay. So I got dy dt is equal to a negative 32 divided by 12. Would everybody agree with that? Should have been negative. Why? Because it's going down, right? And so I could simplify this and I get a negative, I think I can divide by 4, I get a negative 8 over 3. What's my unit? Notice I didn't write my units here. It's going to be feet per second because it's a length, right? It's not area, it's not volume. Are we okay with that? Now, you could write the decimal portion, just make sure you have 3 decimal points. Does everybody understand that? If you don't like a negative 8/3, if it bothers you? Yes, ma'am.
On these tests and quizzes, do you want us to include the units, or can we just do it like that and then add the units later?
You can. I need to have your answer with the units. Okay, now, notice that I circled. Don't circle. Don't box out. Those are all skills that teachers have told you to do so they can be easier to find the answer. Okay? Here's the deal. If you circle, you're telling the person correcting your test, here's my answer. And you might have had the right answer over here and then screwed up. You got it? If you don't circle it, they don't know for sure, so they'll take the right answer. Okay? That's a little trick I learned. So don't circle, don't cross out. Okay? Don't erase. Show work. Try to get as many points as possible. Alrighty? Are we cool on that? Alrighty. So what I'm going to do is give you a bunch of different problems so you see a bunch of different things. And then I'm going to give you some time to work today and tomorrow. Okay? The notes, they only go up to number 9. Is that correct?
Yep.
Okay. There are a couple things, if I don't talk about it here, I have to talk about it on the back of this page if there's room. All right, so here's a common problem. It says a camera is mounted 3,000 feet from the Space Shuttle launching pad. So right here is the Space Shuttle launching pad. So when I draw, I make sure I label some things. It's helpful to get points. So I'm 3,000 feet away. And right here is a camera. Right here, the shuttle is going to be going up. And right here, the camera is going to be focused on this. So imagine me. I've got my video camera. Aren't I going to be going like this? Following it up? Right? You got the idea? And needs to keep the shuttle in focus. If the shuttle is rising vertically at 800 feet per second, what is this right here? It's a rate, correct? It's a rate of what? So I got 800 feet per second. It's a rate of what? What? Okay, I need a variable. It's going up. What do you want to call it? Okay, y. Okay, so this is dy dt. Is that making sense? So y is the distance it went up. Dy dt is how fast it's going up. Does that make sense? Right here I got a 90-degree angle. How fast is the camera to shuttle distance changing? Where's that? Well, you know, it was here, right? Correct? And then it was here, correct? And then it's going to be here, correct? Right? What do you want me to call this? Can I call it C? Because it's the hypotenuse. And so it says, how fast is it changing? I want to figure out dc dt. It's kind of like the ladder problem, isn't it? Like one of the sides is changing, but this time it's not the ladder. Do you see how it's similar to that? So what formula am I going to use? The Pythagorean theorem again. Do you see that? Because it's the Pythagorean theorem is the relationship of those three sides of a right triangle. It shows how they're related, how x, y, and c, a, b, or c are related, correct? So, Hillary, give me what I'm going to write down. Yeah, I don't have x. I do have y squared. Can I write the 1,000 squared here? Does it matter? Equals what? Okay. So I have that. Right? Now, for an instance, it's 400 feet. Correct? What's 400 feet? Y for an instant is 400 feet. For an instant, right? You do not put it here. It's not that I'm not going to use it, but right now I'm not going to put it in here, am I? Okay, does everybody understand that? You understand that this is always 3,000 because the camera's not moving back and forth, is it? Just like the ladder wasn't changing. If the ladder was changing distance, I can't paint. All right, so the next thing, once I get this general, I'm going to take the derivative of that. Hillary, you're on a roll, so let's take the derivative. 0 plus? Nope. Nope. You have to multiply by the derivative of y with respect to time. You need to get the rate of y. Equals times dc dt, which is, so notice that's what I'm trying to figure out, so I need it in there. Now, you should have, I've got 1, 2, 3, 4 variables, correct? I should have some constants that I can substitute in there, otherwise I can't solve for it. Do you see why the 2's are going to disappear? Okay, I have y. Y is 400, correct? And I have dy dt, which is 800, correct? I divided by 2 in my head, correct? Do I have c? No. Can I figure out c? Yeah. So I'm going to put in 3,000 squared plus 400 squared, correct, equals c squared. I'm going to need some calculator help on this one.
How many decimals do you have?
3.
3,026.549.
Okay, here's a good, okay, I'm not going to round it there, okay? I'm going to show you what I'm going to do, okay? And you can do this on a TI the same way you can do it on a Casio, so I'm going to use the Casio. So I'm going to have, turn on here, and I'm going to have 3,000 squared, 300 squared, 3,000 squared plus 400 squared, and then I'm going to go second square root, second answer. You guys know how to do that, right? Go second answer, right? It's a shift. So I'm not rounding this here. I'm going to leave all these decimal points on my calculator. Does everybody understand that? Now, on here, I'm probably going to divide, right, by what Jonathan said, which was 3,026.549, right? Okay, equals dc dt. But on my calculator, I'm not going to do that. Does everybody understand that? Where's Weber today?
I think she's doing the student council.
Oh, Hannah, you got mail. Other Hannah. The palindrome Hannah. Okay. So what I'm going to do is come to my calculator here, and I'm going to take, what was it, 800, 400 times 800 divided by answer. Now I'm going to round. Does everybody get that? I round my answer. If I round too soon, I could be off a little bit. And then they don't give you credit for the answer. Does that make sense? Does everybody follow what I did here? You can't even see what I did. So I did this. That means that's in my answer now. This whole thing to those many decimal points. And then I just took 400 times 800 divided by that answer, and now I'll round. Have you done that before? Anybody? Okay. So my answer is going to be 105.731 what? feet per second. Does it make sense that that rocket is going up at that moment 105.731 feet per second at that time? Okay? I see people saying okay. All right. Can I go to 8? All right, 8. The sand is pouring on a beach, creating a cone. So I'm going to draw a cone. Whose radius is always equal to, so R is equal to twice the height. So my drawing's really bad. I should read the problem first. Here's the radius is equal to twice the height, 2h. Would you agree with that? Do you see where I got that? I don't know, how much do they have you do that in algebra and advanced algebra? Take a look, it's a radius equal to twice h, 2h. Is that pretty complicated or is that pretty straightforward? Okay. It says, if the sand is pouring at a rate of 20 inches cubed per second, there's my rate. Right? Do we agree that it's going to be something like this? Right? We've done that every time. That's how we define our rate. D what? Inches cubed. That's my hint. Would R be inches cubed? It's dV. If sand is poured at a rate, it's the rate that the volume is changing. Everybody okay with that? Now, one thing that's not would happen in here, I would give you that the volume of a cone is 1/3 pi r squared h. Okay, you will be given that. I should have gave it to you in this problem. Some of you may be able to memorize that because you're beautiful memorization people. Okay? Now, right now, if I have to take the derivative, I have to do the product rule. Would you agree? It'd be nice if I didn't have to do the product rule, wouldn't it? Right? Because the product rule is more work. Would you agree with that? All right. So it says, how fast is the height changing? So I want to know dh dt. Would you agree with that? Do I care anything about the radius in this problem? So because I know this, Jeremiah, can I get rid of the radius? Yeah. I can replace r with 2h, correct? So I'm going to change this, and I'm going to have 1/3 pi, and I'm going to put 2h into here, and it tells me to square that, right? Why I do that, Jeremiah, is now I will not have to do the product rule, correct? Which makes it a lot easier. If I did the product rule, McKenna, I could still get it correct. But can you see I'm just going to use the power rule now? It makes it really, really nice. So I'm going to continue with this, and I got V equals, and I'm going to have 4/3 pi h cubed. So what I did is I took 2h and squared it and got 4h squared, multiplied by 1/3, and that's where I got 4/3. And then h squared times h is h cubed. Okay with that, with everybody? I can make that jump? Cullen, do you feel confident of taking the derivative of this? Okay, what is it? dV dt, because that's a variable that's changing, right? Equals what? What is 4/3 times 3? 4. Pi h squared, perfect, times dH dt. And I'm trying to find dH dt, right? Right here. So, do I know dV dt? I hear people saying, yes, that's 20. I've got 4 pi. Ooh, ouch. I don't know h. Can I figure out h? Does it tell me h? Oh, it's 6 inches. Awesome, I do know h. Do I put a 6 in here? Did I put 36 in there? I'm going to put, yeah, this is inches cubed. I am going to put 6 in here, right? And I'm going to do what? Square it? So you said it's squared is 36, correct? That's 6 squared times dH dt. So dH dt is equal to what? 5. How did you get 5 so quickly in your head? Divide by 20 by 4, right? And now you're going to divide by what? 36 pi. And make sure that pi is underneath, right? Again, you can figure out what the decimal is on your calculator. Make sure you put 36 pi in parentheses. Does everybody understand that? Now, what's my units? It's how fast this height is growing, correct? Is it cubic? No. It's what? Inches per second. Is everybody okay where we get inches per second? Because the height is 6 inches, so it's growing inches per second. Are we okay with that? I'm looking around and I think you're okay. This is like a, Hannah, this is like a lot of stuff. Are we doing okay? You sure? Because I didn't get much sleep last night. All right, we ready to the next one? The next one says, water is draining from a conical tank. So it's a cone again. So the volume is 1/3 pi r squared h. I should have had that in there. Okay? And it's draining at a rate of 2 meters cubed per minute. So I got 2 meters cubed per minute equals dt down here, right? D what? Is it dH? Look at your units. Why is it dV? Because it's because it's meters cubed, correct? If it was meters squared, it'd be area. If it was meters, it'd be something else. Would everybody agree with that? The tank is 16 meters high, so I better draw my picture. Oh, so the tank looks like this. It's like an ice cream cone. So it's 16 this way and 4 this way. Would you agree? Everybody okay with that? How fast is the water level falling when the level is 2 meters high? What am I trying to find? Right, it's leaking out of here, right? Here are the drops, it's leaking out. And so right now, eventually it'll be like this high, correct? Right? And then it'll be this high, right? How fast is the water falling? dH dt. Perfect. Okay? Positive or negative am I looking for as an answer? Negative, right? Because it's falling. Everybody got that? Okay. Oh, yeah. Thank you. It better be negative. Way to catch me. Awesome. Because it's draining out of there, right? It's decreasing. Okay, now, I'm thinking I got to do a product rule again, correct? Oh, with a cone, you don't have to ever use the product rule. So I'm going to go back in time. I'm going to draw this right here. This is the radius. This is the height, correct? Oops, what was it, 16, sorry. Correct? That's when it's full. Would you agree? When it drains, here's a part where it could be when it drains, right? And this would be the radius, and this would be the height. Everybody with me there? I have two triangles. Would you agree? A big triangle, Tyler, and a little triangle. And they're both right triangles, aren't they? Right? This is true for every right cone. Notice that these right triangles, these two little ones, this one and the little one, both share this angle, correct? And these angles, so these two angles would have to be the same. So the three angles of the big triangle are equal to the three angles of the little triangle. We say when that happens that the triangles are similar. Do you remember similar triangles? What is nice about similar triangles that you may forgot was that the sides are proportioned to each other. Do you remember that? So that means radius to height of the small triangle has to be equal to 4/16 of the big triangle. Are you okay with that? That means 16R is equal to 4H. Are we okay with that algebra? Now, I'm trying to find dH dt, correct? Do I even care about R? So just like the last problem, I'm going to get things in terms of H. Are you okay with that? So that means R is equal to 1/4 H. You with me on that? Everybody cool? That is always true when they give you a cone. It's always true when they give you a right cone. And they'll always give you a right cone. So you can avoid doing the product rule if they give you a right cone. So now what I'm going to do is I'm going to come to my volume, and I got 1/3 pi. I'm going to put 1/4 h in here, and I'm going to square it times h. So that means my volume is going to be 1/48 pi h cubed. 1/4 is 1/16. If I square it, multiplied by 1/3 is 1/48. So that means dV dt is equal to, I think, 1/16 pi h squared dH dt. Cullen, I think that's how you did it last time. Am I right? Okay. Now I can plug in stuff. This is a -2 because Jonathan said it's negative, correct? This is 1/16. This is pi. This is dH dt. What do I need here? Oh, it says when it is 2 meters high, correct? Right? So I can put a 2 squared here. Everybody see where I got that? So that means I'm going to draw it over here and give myself some more room. So I got negative 2 equals, this is 4. 4 over 16 is 1/4. Am I correct? 1/4 pi dh dt. So I'll get a negative 8 over pi equals dh dt. What are my units? Meters per minute. Are we doing okay with that? Okay. I want to give you 2 problems. Is there a backside? No? Okay, so you're going to want to put these in your notes. Oh, values draining. Is that better? Is that better right there? Okay, I think that'll be enough, all right? So you have this, I suppose you could think of it as a barrel, right? Have you seen barrels? This is a small one, or a can or something like that. And it's got water in it and it's draining, okay? And it's draining at a rate of this. So 3 inches cubed per second is what, dt? dV dt. Now, again, the volume of a cylinder, I should have given that to you. It's pi r squared h. Now, let's say right here it's this full. What's the radius when it's that full? What? Yeah, it does. Okay, thank you. Okay. Yes, it is. Okay. What is the radius when it's that full? 5 inches. What about if it's this full? What about if it's this full? So unlike the cone, the radius is a what? Constant. Would you agree? When it drains, only the height changes. So really, I can write this as 25 pi h. Does everyone see that? It makes it really easy, doesn't it? Because the radius on a cylinder is always a constant. So the derivative is dv dt equals 25 pi dh dt. So it's always at a constant change, isn't it? Right? It doesn't matter it's 2 inches. At any particular time, it's going to be decreasing at a constant rate. Does everybody see that? So this is going to be a negative 3 is equal to 25 pi dh dt. So your answer is a negative 3 over 25 pi equals dh dt. And my units are what? Inches per second. Okay? Everybody got that? One more problem and then I'm done. Has everybody got that? So I want to go to this problem. And it's this rocket. I'll write it like this. Remember this rocket right here. Here's my camera. I'm at 3,000 feet. And it's being launched like this. Right? Remember this? And I think it was rising at, what was it? 800 feet per second? Yep. Like this?
Yep.
And so that I think we call dy dt. Am I right on that? Correct?
Yeah.
Right? And it said that y was 400 feet for a brief moment. Correct? So, this theta right here, I'm going to put a theta here. Have you ever seen the symbol theta for an angle measurement? Okay? Okay, now, this is a very common problem. When I got my camera and I'm looking, my angle is changing, correct? It's rising. We call that the angle of elevation. Does that make sense? So remember when I said we're going to use trig for when we figure out rates in which the angle changes? So they're going to ask you, what rate is that angle, the camera, that angle, the camera angle changing? You got the idea? So what you need to know is you're talking about, here's a 90-degree angle, you're talking about this side, and you're talking about that side, correct? What trig function is that? Tangent. Does everybody see that? So I can write tangent of theta. So if I want to know how fast the angle is changing, I want to find out, first of all, what d theta dt is. That's the rate that the angle is changing. So I got the tangent of theta is equal to y over 3,000. Opposite over adjacent, correct? So I could write that as the tangent of theta equals 1 over 3,000 times y. Now I'm going to take the derivative. What is the derivative of tangent? It's one you have to have memorized. Secant squared times d theta dt, which is what I want, equals 1 over 3,000 dy dt. Everybody with me so far? So now I have this. D theta dt is equal to 800 over 3,000. Does anybody know where I got the 800? That's d, yeah, 800 is dy dt. Very good. Now I'm going to divide both sides by secant squared, correct? Would everybody agree? So down here I got 1 over secant squared theta. Well, that's the same as, I'm going to cross, get some zeros out of here, 8 times cosine theta squared, correct? Over 30. It'd be nice to know what cosine theta was, right? Correct? I know that for a brief moment this is 400. Would you agree with that? So this is the square root of 3,000 squared plus 400 squared. Would you agree with that? Cosine is adjacent over hypotenuse, right? So the cosine of theta is going to be 3,000 squared plus 400 squared, the square root of that, divided by 3,000. Oh, I got it backwards. Don't I? Sorry, I didn't get enough sleep. 3,000 over the square root of 3,000 squared plus 400 squared, correct? Which I can figure out on my calculator, correct? So what is the cosine of theta on your calculator? Say it again. 0.991. Okay. Does everybody confirm that? Is that right? Okay, so if I square it, what do I get? 0.983. So I squared it. You're going to multiply it by 8, divide by 30. And d theta dt is equal to what? 0.262. What are your units? No. No, but you're closer than feet.
Yeah.
We don't use degrees in this class. Radians, or what I call rads. For a second. Okay. Okay.